Greetings, Tom Woods School of Laborers. Welcome to week 2 of my business analysis series. I've been doing computer simulation for most of my career, and that's what taught me everything I know about doing business analysis. All that experience allowed me to earn the certification in the field very easily, and learning that business analysis actually helped me understand what worked really well during my career in the organizations I was in and what did not work. I had a kind of inchoate feel for what was happening, but when you can really understand something deeply and put words to it, that becomes way more powerful. So I am sharing these insights with you. These presentations, the slides for them are all on my website as shown. The videos are recorded for everything, stored on YouTube, and also linked on my website. So one thing to know about these slide decks I share with you is that they're executed in the reveal.js framework. So they are natively hosted, they are interactive HTML and JavaScript with live links. So if you get into these things, you can click on any of these orange links and go to a whole host of other materials on my website and elsewhere. So there are two major classes of simulation. Continuous simulation is based on differential equations that are used to model physical systems, fluids, electricity, vibration, stress, that kind of thing. And discrete event and also Monte Carlo systems that model events in any particular kind of time step. And here are examples of two. They can be written in any language. I have developed these things from scratch, from first principles in high level languages, so I understand how they work at a deep level and how to work with them and do everything it takes to build them by myself and in large groups. I've done this in a number of industries. Almost any industry can use simulation. There are many different applications. I write about them, some in a different article or a blog post, and there are different architectural considerations. I talked about some of those last week. So where do we start building a simulation or solving a problem and or building a system or improving some operation for a customer? Before all this bizarre stuff happened to me, I did swing dance for a long time, traveled all over the country, and really had a great time with it. I'm not claiming I was any good at it, but I certainly did have fun. And I learned a lot, both about dancing and about a lot of other things. My favorite dance is actually begins as something really simple. If you think about a foxtrot, for example, you have a basic box step, and they'll teach you how to do that dance based on that step. It's a place to start. Uh, my favorite dance is almost even simpler than that. I could show you in a partner how to do it in 5 minutes. Now, there are infinite number of variations on this thing, and you can spend the rest of your life learning those variations, learning more about dancing in general, doing all kinds of other crazy things. There were so many different ways to do that, that back in when the dance was popular, after it was originally created, people could tell what high school you went to by the way you did your basic step. So there are a lot of ways to solve problems, and they'll be driven by a lot of different considerations, but we have to start somewhere. So I'm going to show you one way of thinking about that to start, and then over subsequent weeks, I will go into different variations, combinations, permutations. One thing, there are standard things you do when you're solving a problem, in knowing what they're called and what you do in the various steps always improves your situational awareness and helps guide what you do, how you think about it. So in or someplace, or so I'm saying, here's, we have to start someplace, here's our someplace. We're talking about simulating or improving a system that already exists. The purpose will be, and these considerations are less important. We want to improve the operation of an existing system. It doesn't have to be real time or interactive, so it's kind of simple. And it's a process system. So a car isn't a process, it's a thing. There are processes in it, but for business analysis, we're usually talking about some kind of process where things come in, they get stuff done to them, and they go out and things change and decisions are made. So who is going to be involved? All this work can be done by yourself, but it's also possible to do this work in more groups of different sizes. If you're going to work with other people, that involves communication, and if you're communicating, you have to have empathy. You have to talk each other's language. So it's good if you're already in an industry, you already know each other's language. But if you don't, one of the early steps is to actually learn it, and that can be explicit or not, but it has to happen. You won't get everything right the first time, so what you need to do is listen, document, review, and correct, and you keep doing that iteratively until everyone is in agreement. And there is a more complex process for that or context, and we'll go into that in the future. And all this happens in a managed environment with limited resources. So step one is figure out what your problem is and what you want your solution to do. There are a lot of reasons to write and run simulations and do other things. There are infinite numbers of business problems and processes that need to be created and improved. You have to provide value, otherwise there's no point in doing it. It has to be accurate enough to be meaningful. Remember, especially about simulations, that all of them are wrong, some are useful, and the usage may change or grow or be added to or have items taken off of as you learn throughout the process. So you need to understand the thing you're going to simulate. Remember that we're talking about an existing system. So the first thing you want to do is figure out what's going on now. And that's a process called discovery. And there's a link to a longer article about it. So when you do discover, you're finding out the components and the actions that happen. These are your nouns and verbs. Most systems have components that do standard things. You have inputs, you have outputs, you can call them entries and exits. You have processes, you have queues, you have holding areas, they might be bags, that kind of thing. Different industries and systems within those standard things will include processes and machines and equipment and infrastructure to support all those crazy things. There are a lot of ways to do all this. Use all of them that make sense for the situation. Once you understand what's going on, you want to characterize the system. And that is your adjectives and adverbs. How many, how much, how long, how fast. So first is the what, second is the numbers. And there are infinite types of data, but they have some characteristics in common. I will discuss that in future weeks. Learn what the data all mean and document everything. So again, that is part of speaking each other's language and reviewing it to make sure everyone has the same understanding. There are a lot of ways to do this work also, use them all, and the data may be messy, it may not be clean, and this comes up all the time. So figure out how to make it usable or otherwise deal with the imperfections, what's missing, and so on. So now that we have our problem statement and we have our understanding of what's going on, we have to understand the details of what the people in this solution actually need. So if you're improving the process of serving coffee, say at a Starbucks, how can you make it better? You need to understand the customers, the workers that are in the store, the suppliers, the computer systems, the infrastructure, what's behind the counter, and so on. So all those individual people have needs, and the solution has needs of its own depending on what you're going to do. The more we know about the kind of solution we're going to develop, and the earlier we know it, the easier it'll be. Easier it will be to support that when we come to implementation. So there are two things about a solution or a system. We want to think about what the solution does, and we want to think about what the solution is, and they're different. So answering the business need is what it does, but how it does it is very important. There is specific vocabulary for this, and I'll go into it in the future. And we want to define the criteria by which our solution and our requirements will be judged. So we want to generate multiple solutions, perhaps, and then pick the best one, or we want to develop the one kind of solution in detail we're prepared to apply. So a system should, if we're doing a simulation, should include and describe everything the existing system does, unless everyone agrees that simplifications can be made. For example, in a nuclear power plant, if we're doing an operator training simulator, we don't have to worry about certain clean out loops and sample boards and everything like that. They're on the process and instrumentation diagrams. There would be extra machines sometimes, but they're not part of why we're exercising the system, so we omit those things. And I'll go into that in the future as well. There are a lot of reasons to do that. We should understand the risks of taking any shortcuts and omitting things. There are a lot of different ways to evaluate and rank solutions to choose the best one, and they'll differ based on what you're doing. A classic way to do it is by what has the best net present value, considering all the costs and benefits. However, not all criteria can be calculated and expressed in money. So different organizations may be driven by different things, particularly nonprofits. So the full solution and the design of it should consider the entire life cycle, not just what's going to be running. So now we build and deploy the solution or the simulation. It should be as simple as possible, but not simpler. So it should meet all the requirements, but it shouldn't have extra fluff just because it's cool or you want to make it some kind of complete based on something logical in your mind. Don't worry about that. Only build things the solution actually needs. You may need to roll it out in phases. There are a few ways to do it, either different parts of the solution over time or the entire solution only to a part of the user base so they can get used to it and do some initial testing, training, and break-in so you can do the wider rollout more effectively. Again, we have to consider the full life cycle. I always try to make solutions as standard and modular as I can. I like to build the smallest number of standard-ish components and stick them together like Lego. But especially when you're attacking a new problem, it takes time to figure out how to do that. As we know from the development of consumer products, the initial ones tend to be expensive, customized, and brittle, and over time they become standard, cheap, and robust. So think how much better cars are now. I know government interference has done some weird things to them, but they really overall have gotten way better, and they last a lot longer. And then we do the appropriate testing and acceptance. We should test thoroughly. We should plan for how we're going to test it right from the beginning. Solutions should be judged on how they work. So that's a kind of qualitative way that they work in, or that's a quantitative way, and they should also be judged on how well they meet the actual business need. And that can be a little more loose or abstract or nebulous. As much as possible, we want to have defined tests that give yes, no answers, but some kinds of tests are better at this than others. Think total quality management says we define a standard and we either do or do not meet that standard. But what are the exceptions? Think test-driven development is you write all the tests that you want the system to pass, and then you only develop enough to pass those tests. Remember, the market test is the most important. The best solution doesn't always win, and that is not necessarily a test you can perform in-house. So there are different kinds of tests. So in summary, we define the problem, figuring out what's going on now, identify needs, design something, build it, and test it. That's basically the process. We do that for a simulation, and we do it for any other kind of solution. Now, if we want to put that in a project management wrapper, what we'll do is we'll start the process and get resources for it, and we'll close in. We'll also do some work to negotiate what to include or not include, and we'll call out data management separately. It can become a very big issue. Here's another way of saying the same thing. So we do planning, we do closing. We uh, define the problem as our intended use. That language comes out of doing simulation, but you can call it anything. We do assumptions, capabilities, limitations, and so on. And that really happens not in a particular place, but is an ongoing activity through the whole process. Then we do a conceptual model, and that really gives us the as is state. And that is figuring out what's going on. And there are other contexts for conceptual modeling, and I'll go into those in the future. Then we deal with data, then we do the requirements. Now, requirements, when you define them, that gives you the to be state in an abstract form. And they're functional, which is what it does, type requirements, and requirements that are about what the solution or the simulation is are non-functional requirements. And they're usually discussed in terms of entities. Um, uh, which is, well, I'll go into that. Then a design is a to be state in detail. It's what you're actually gonna build. Then you do the implementation, you do testing. So there are two major kinds of testing. The operation, usability, and outputs are called verification. They're most able to be automated, and they have yes, no answers. Validation is about the outputs and the fitness for the purpose. How well does it solve the problem? That is validation. That can be more nebulous. Then we do acceptance or accreditation, and that is your project flow. The way I represent that is I streamline and stylize it, and then I talk about different ways all those steps, all those activities occur in different management contexts. So in waterfall, in theory, you do them in order, especially if you have an existing system. In Agile or Scrum, what you're doing is the first half of the project to create backlog items, and then you're picking items out of the backlog and iteratively doing the back half of the process and rolling out incremental builds or what have you. In a hybrid situation, you may have an overarching design, and you may be building it in an iterative, agile fashion. Now, if we're doing an existing project like I've discussed so far, just as a place to start, we do the conceptual modeling, the discovery, and the data collection in the beginning phase once we've figured out what we're trying to do. But if we're starting from scratch, if there is no existing system, we actually embed all that work in design. So it's really conceptually the same work, but we do it in a different order. And simulations used to design and build things are a whole interior project of their own that is embedded within design and implementation. So here is the last slide, the most important one, and what I've been trying to get to all this time. What I'm trying to show here is in every step, even in waterfall, you don't just do one step, do the next, do the next, do the next, and march right through and have a solution, and you're done. It never happens that way. There always should be, and there always is, because humans aren't perfect. A lot of iteration within each phase. So, for example, if you're doing your initial discovery and data collection, you'll have SME show you what's going on, you'll document it, they'll review that and say, no, you got this wrong, and this thing and that thing, and you'll fix it, and you'll keep doing that, iterating in this loop until everyone agrees you've got it right. And you do that in every phase, but you'll also iterate between phases. Now, the classic way of doing this is when you're building the implementation, you'll do tests, and when the tests don't pass, you ship it back and re-implement it, and you might even redesign it. And you may figure out somewhere along the line you need to add more basic stuff to it, or you forgot to include some aspect of the existing system, or there's something even more fundamental in the definition of the entire problem that you missed. So we're always iterating within and between phases, and everything I'm going to talk about in subsequent weeks will really hammer on this point. So that is my website and my contact information. Thank you very much for attending today. I really appreciate it. I am go ahead and ask questions if you have any.
Bob, do you, to me, this is a little abstract. When I came in not knowing exactly what business analysis referred to, do you have, can you summarize maybe like a case study? And I have a much better idea now, you know, having seen the presentation here. I think I get the main idea, but if you had a little, you know, a story of a case study or something where you use these techniques, or even just a theoretical one, how it would look in reality, then that would be illustrative to me.
Well, a classic one is, let's say we have an existing system that processes a lot of papers, for example. Say in the old days, people used to charge things on their credit card. They'd actually put your plate with the embossed letters in a machine. They'd run a roller over it that would impress on several layers of carbon copies, and somebody would sign it. You give the customer a receipt, you keep the other part of it, and you send that into the credit card company. And then they would receive zillions of these things. And they would, over time, read them all, figure out whose account it was, add the balance to the account, check against credit limits and all that kind of thing, make phone calls to do verifications and so on, and then make sure they would accept payments, they'd send out bills and questions and supplementary communication. Now, if I wanted to change that process in some way, for example, if I wanted to automate it, right? I wanted to replace more and more steps with things done on computers in time. The first thing I would do is I would find out everything that's going on. I would talk to as many managers and SMEs as I needed to figure out what's happening right now. And then I would figure out, okay, what do we really need? And that is, we have to serve all the different users in the process, and we have to serve the customer, we have to serve banks, and so on. So we'll talk to them and find out what's needed. And then we'll figure out, okay, how are we going to design something that automates this? And ideally, we might first start with scanning all the pieces of paper when they come to the office. And then we only touch the paper once. And instead of handling all the pieces of paper and shuffling them around and filing them and collating them and getting them in folders for similar vendors or similar accounts, we do it all with computers and automate, and then all the work having to do with that physical paper goes from moving it all around in folders and not losing it and running the risk of destroying it. And now we can save all that effort. Instead, we'll scan it and we'll put it in a warehouse for 90 days. We'll say the heck with it. And that process is we have to buy all the computers, but and write all the software, but that's simpler than and cheaper than dealing with the material, right? And then you actually do a design for how that's going to happen. Then you build it, then you test it. So automation is one classic way. And I actually did that with numerous systems using FileNet, which was a kind of business automation tool where its real strength was document imaging. And in the 90s, that's what a lot of businesses did. And over time, they don't even have the paper. Now it's all electronic. So it's a lot more streamlined. So those, I know it's hard unless you have a story, and I should probably come up with a clear description that answers that mail. But once you see it a few times, it just beats you in the face. I mean, you just see that process everywhere.
Right. So you've described modernizing a paper-based system but you're also, your thesis in this talk is that you want to simulate the adoption of this process. Like the
Oh,
simulation end of it is what? You predict how much money you're gonna save or something as you transform it?
You might do that. I talked about simulation last week, and you can think of a business system as a human in the loop simulation. So it's a process where stuff comes out based on decisions that goes to different places. Things get merged. If you think about an assembly line, so a car chassis will come by, and different things get added to it, and there's data that say what are the options I'm making on this car. So it'll go get painted a different color, or it'll have different headlights or different trim put on it. And that may be in response to I'm making X of those, Y of those, Z of those. But here's the Joe Blue in Poughkeepsie who wants a special combination nobody else gets. And it's really trying to keep track of all that. And there are so many ways to um, improve or change existing processes and build new ones. So I'm not talking so much about ultimately building simulations, just building simulations. Thanks for coming, Mark. Is a point of departure that gives context. So if you're going to build a simulation, as I've done in many contexts, you have to do the same thing for building any business system. And I had one incomplete thought, which is that there are a lot of ways to improve things. Automating things is one, improving individual components within a process is another, and rearranging the components to do them in a different order is even another. So there are a lot of ways to do that.
Okay, I understand. Thank you. That's all the questions I have.
All right, sounds great. I will be doing this every week. If you have specific questions that I don't address over time, then feel free to contact me and let me know what questions you'd like me to address.
All right, sounds good. Well, thanks
All
for
right,
the talk, Bob, and virtual applause, not laugh track, but applause track from the audience. All
thank you, sir.
right, see you next time.